We have all played games like Ludo, Snakes and Ladders, or even Roulette. And let's be honest, while throwing the dice, haven't we all secretly wished for it to land on a specific number? But here's the question: what's the science behind that wishful thinking? The answer is probability. Probability is the measure of how likely an event is to happen, ranging from 0 to 1. A probability of 0 means the event is impossible, while 1 means it's certain. Everything else? That's where the magic of uncertainty unfolds. Alright, we have established what is probability. Now let's try and understand more of it with another simple example. Imagine a bag filled with marbles. There are 2 red, 3 blue, and 5 green marbles in a bag. If you randomly pick a marble from the bag, what are the chances of it being blue? The probability of picking a blue marble is simply the ratio of the number of blue marbles to the total number of marbles. We'll use this notation to represent probability throughout. Now let's see if we can express this visually using a Venn diagram. Here, the large circle represents all possible outcomes, the total number of marbles in the bag. The smaller circle represents the specific event we are focused on, the blue marbles. Let's take it up a notch with a game of chance. Imagine a spinning wheel divided into 4 equal sections: red, green, yellow, and blue. You win the game if you land on the same color twice in 2 spins. So, what's the probability of landing on red both times? First, the probability of getting red in a single spin is straightforward. There is one red section out of 4 total sections. This means the probability is 1/4 or 25%. Now, let's calculate the probability of landing on red in 2 consecutive spins. We will simply multiply the probabilities of each spin. The probability of getting red on both spins is 1/4 multiplied by 1/4 spin equals 1/16. So, the probability of landing on red twice is 1/16 or 6.25%. Let's make this even more visual. Imagine a grid where the rows represents the outcomes of the first spin and the columns represent the outcomes of the second spin. When you fill in this grid, you see all 16 combinations. The intersection of the first row and the first column, representing red on both spins, is our desired outcome. Using this matrix approach, we can clearly see the total number of possibilities and pinpoint the specific combination we are calculating. Whether it's a matrix or a Venn diagram, these tools help simplify probability problems and make the concepts crystal clear. From marbles to spinning wheels, probability helps us quantify the uncertainty in our lives. And the best part, it's not just about games or numbers. It's a skill that can help us make informed decisions in real world scenarios. Don't forget to practice with more examples to solidify what you just learned. I will see you in the next video.